The North American X-15 rocket-powered research aircraft bridged the gap between manned flight within the atmosphere and manned flight beyond the atmosphere into space. After completing its initial test flights in 1959, the X-15 became the first winged aircraft to attain velocities of Mach 4, 5, and 6. That's an impressive 4, 5, and 6 times the speed of sound. Because of its high-speed capability, the X-15 had to be designed to withstand aerodynamic temperatures on the order of 1,200 degrees Fahrenheit. As a result, the aircraft was fabricated using a special high-strength nickel alloy named Inconel X. Air-launched from a modified Boeing B-52 Stratofortress aircraft, the X-15 required conventional aerodynamic control surfaces to operate within the atmosphere and special thrust reaction control rockets located in the nose and wings of the aircraft. To enable the pilot to maintain control when flying on the fringes of space. Indeed, the X-15 design was so much like that of a space vehicle that during the formative days of Project Mercury, North American and National Air and Space Administration engineers gave serious consideration to utilizing a growth version of the X-15 for the manned orbiting mission. This plan was dropped in favor of using a blunt-body re-entry vehicle, because of the potential dangers to the pilot should the X-15's pressurized cockpit lose its atmosphere while the aircraft operated in a near-space environment. X-15 pilots wore specially developed full-pressure protection spacesuits while flying the experimental plane. Three X-15 research aircraft were built and flown, completing a total of 199 research flights. The National Air and Space Museum has the historic X-15-1, Air Force Serial 566670. The X-15 No. 2, Serial number 56, 6671, was rebuilt following a landing accident, as the advanced X-15 had an increased propellant capacity and therefore it had a higher potential performance. The X-15 No. 2 was the fastest X-15 flown, and it is now on exhibit at the Air Force Museum Wright-Patterson Air Force Base in Ohio. The X-15 No. 3, Serial number 56, 6672, featured an advanced cockpit display panel and a special adaptive control system. The aircraft made many noteworthy flights until it crashed during atmospheric re-entry, following pilot disorientation and a control system failure. The test pilot, Michael Adams, was unfortunately killed. The X-15 flew faster and higher than any other airplane. A peak altitude of more than 354,000 feet, approximately 67 miles, was reached by the X-15. And the X-15 version 2 attained a speed of Mach 6.72, or 4,534 miles per hour. While testing a new ablative thermal protection material and a proposed design for a hypersonic ramjet, Various proposals were set forth for modifying the aircraft to accomplish new and even more radical tasks. At one point, NASA's scientists planned to test a hydrogen-fueled supersonic combustion ramjet engine mounted on the X-15's lower vertical fin. A mock-up of this proposed installation was flight tested on the X-15 version 2. Other ideas included modifying the X-15 with a slender delta wing and using the aircraft as a booster for small satellite launch vehicles. None of these ideas, however, came to fruition. The X-15 spearheaded research in a variety of areas, like hypersonic aerodynamics and winged re-entry from space. Also, life support systems for spacecraft, aerodynamic heating and heat transfer research, and earth sciences experiments. A total of 700 technical documents were produced, equivalent to the output of a typical 4,000-man federal research center for more than 2 years. Development of the X-15 began in 1954, and keep in mind, that's almost 70 years ago. North American was selected as prime contractor on the project following a competition in which Douglas, Republic, and Bell also participated. By the time of its first airborne test, flight research was too complex to rely on simple air-to-ground communications near a test field. The Air Force and the National Advisory Committee for Aeronautics developed a special 485-mile-long test corridor stretching from Wendover Air Force Base in Utah to Edwards Air Force Base in California. It was planned that the X-15 would be air-launched from a Boeing B-52 near Wendover, then fly down this corridor, the high range, to Edwards. Monitored by tracking stations at Ely and Beatty in Nevada, and at Edwards, the range lay along a series of flat dry lakes, where the X-15 could make an emergency landing, if necessary. Nothing this extensive had previously existed in flight research, and it foreshadowed the worldwide tracking network developed by American manned spacecraft ventures. The X-15 would complete its research mission and then, followed by a special Lockheed F-104 aircraft, would land on the hard clay of Rogers Dry Lake. Because the X-15 featured a cruciform tail surface arrangement, it was necessary for the designers to make the lower half of the ventral fin jettisonable prior to landing, so that the conventional two-wheel nose landing gear and two tail-mounted landing skids could support the aircraft. The X-15 was based on a concept study from the National Advisory Committee for Aeronautics for a hypersonic research aircraft. The requests for proposal were published on the 30th of December 1954 for the airframe and on the 4th of February 1955 for the rocket engine. The X-15 was built by two manufacturers. North American Aviation was contracted for the airframe in November 1955, and Reaction Motors was contracted for building the engines in 1956. Like many X-series aircraft, the X-15 was designed to be carried aloft and drop-launched from under the wing of a B-52 mothership. Two Air Force B-52s, called the High and Mighty 1 and the Challenger, served as carrier planes for all the X-15 flights. Release of the X-15 from the B-52 took place at an altitude of about 8.5 miles and a speed of about 500 miles per hour. The X-15 fuselage was long and cylindrical, with rear fairings that flattened its appearance and thick dorsal and ventral wedge fin stabilizers. The outer skin were heat-resistant nickel alloy. The retractable landing gear comprised an O's wheel carriage and two rear skids. The skids did not extend beyond the ventral fin, which required the pilot to jettison the lower fin just before landing. The lower fin was recovered by parachute. The X-15 was the product of developmental research, and changes were made to various systems over the course of the program and between the different models. The X-15 was operated under several different scenarios, including attachment to a launch aircraft, drop, main engine start and acceleration, ballistic flight into thin air and space, re-entry into thicker air, unpowered glide to landing, and direct landing without a main engine start. Attachment to a launch aircraft, drop, main engine start and acceleration, ballistic flight into thin air and space, re-entry into thicker air, unpowered glide to landing, and direct landing without a main engine start. The main rocket engine operated only for a relatively short part of the flight, but boosted the X-15 to its high speeds and altitudes. Without main engine thrust, the X-15's instruments and control surfaces remained functional, but the aircraft could not maintain altitude, as the X-15 also had to be controlled in an environment where there was too little air for aerodynamic flight control surfaces. It had a reaction control system that used rocket thrusters. There were two different X-15 pilot control setups. One used 3 joysticks, the other, 1 joystick. The X-15 had multiple control sticks for the pilot, and they were placed a traditional center stick between a left 3-axis joystick, which sent commands to the reaction control system, or RCS, and a third joystick on the right used during high-G maneuvers to augment the center stick. In addition to pilot input, the X-15 Stability Augmentation System, or SLS, sent inputs to the aerodynamic controls to help the pilot maintain attitude control. The Reaction Control System, or RCS, could be operated in two modes: manual and automatic. The automatic mode used a feature called Reaction Augmentation System, or RAIS, that helps stabilize the vehicle at high altitude. The RS was typically used for approximately 3 minutes of an X-15 flight before automatic power off. The alternative control setup was named MH-96 Flight Control System, which allowed one joystick in place of 3 and simplified pilot input. The MH-96 could automatically blend aerodynamic and rocket controls, depending on how effective each system was at controlling the aircraft. Among the many controls were the rocket engine throttle and a control for jettisoning the ventral tail fin. Other features of the cockpit included heated windows to prevent icing and a forward headrest for periods of high deceleration. The X-15 had an ejection seat designed to operate at speeds up to Mach 4, or 4,500 kilometers per hour, or 2,800 miles per hour, and 120,000 feet, or 37 kilometers altitude, although it was never used during the program. In the event of ejection, the seat was designed to deploy fins, which were used until it reached a safer speed altitude at which to deploy its main parachute. Pilots wore pressure suits, which could be pressurized with nitrogen gas, above 35,000 feet altitude. The cockpit was pressurized to 3.5 psi with nitrogen gas, while oxygen for breathing was fed separately to the pilot. The initial 24 powered flights used two reaction motors XLR-11 liquid propellant rocket engines, enhanced to provide a total of 16,000 pounds force of thrust, as compared to the 6,000 pounds force that a single XLR-11 provided in 1947 to make the Bell X-1 the first aircraft to fly faster than the speed of sound. The XLR-11 used ethyl alcohol and liquid oxygen. By November 1960, Reaction Motors delivered the XLR-99 rocket engine, generating an impressive 57,000 pounds force of thrust. The remaining 175 flights of the X-15 used XLR-99 engines in a single engine configuration. The XLR-99 used anhydrous ammonia and liquid oxygen as propellant, and hydrogen peroxide to drive the high-speed turbopump that delivered propellants to the engine. It could burn 15,000 pounds of propellant in 80 seconds. Jules Bergman titled his book on the program, 90 Seconds to Space, to describe the total powered flight time of the aircraft. The X-15 reaction control system, made for maneuvering in the low pressure and density environments, used high-test peroxide, or HTP, which decomposes into water and oxygen in the presence of a catalyst and could provide a specific impulse of 140 seconds. The HTP also fueled a turbopump for the main engines and auxiliary power units. Additional tanks for helium and liquid nitrogen performed other functions. The fuselage interior was purged with helium gas, and liquid nitrogen was used as coolant for various systems. Before Neil Armstrong walked on the moon and before he flew on Gemini 8, he was a test pilot. Noted for his engineering excellence and technical capability as a pilot, Armstrong became one of only 12 pilots to fly the ultimate experimental aircraft, the North American X-15. Armstrong enrolled in Purdue University in 1947 under the innovative Holloway Plan, which paid for the student's education in exchange for service as an officer in the Naval Reserve Officer Training Corps. After 2 years at Purdue, Armstrong was called up by the Navy and, after completing flight school, flew 78 combat missions in Grumman F-9F Panthers during the Korean War. Altitudes attained by X-15 aircraft fell short of those of Alan Shepard's and Gus Grissom's Project Mercury space capsules in 1961, or of any other human spacecraft, except the Spaceship Two spaceplane. However, the X-15 ranks supreme among crewed rocket-powered aircraft. Becoming the world's first operational spaceplane in the early 1960s. Before 1958, United States Air Force discussed an orbital X-15 spaceplane, the X-15 version B, that would launch into outer space from atop an SM-64 Navajo missile. This was canceled with the birth of Project Mercury. By 1959, the Boeing X-20 Dinosaur space glider program was to become the preferred means for launching military crewed spacecraft into orbit. This program was canceled in the early 1960s before an operational vehicle could be built. Various configurations of the Navajo were considered, and another proposal involved a Titan I stage. 3 X-15s were built, flying 199 test flights, the last on the 24th of October 1968. The first X-15 flight was an unpowered glide flight by Scott Crossfield on the 8th of June 1959. Crossfield also piloted the first powered flight on the 17th of September 1959, and also his first flight with the XLR-99 rocket engine on the 15th of November 1960. Among these heroic American test pilots was Joe Engle, later a commander of space shuttle missions. In 1962, X-15 was considered as a launch platform for a Blue Scout rocket to place satellites weighing up to 150 pounds into orbit. In July and August 1963, pilot Joe Walker exceeded 100 kilometers in altitude, joining American astronauts and Soviet cosmonauts as the first human beings to cross that line on their way to outer space. On the 15th of November 1967, Air Force test pilot Major Michael Adams was killed during X-15 Flight 191 when his X-15 entered a hypersonic spin while descending, then oscillated violently as aerodynamic forces increased after re-entry. As his aircraft's flight control system operated the control surfaces to their limits, acceleration built to 15 Gs vertical and 8.0 Gs lateral. The airframe broke apart at 60,000 feet altitude, scattering the X-15's wreckage across 50 square miles. On the 8th of May 2004, a monument was erected at the Cockpit's locale, near Johannesburg, California. Major Adams was posthumously awarded Air Force astronaut wings for his final flight in X-15, which had reached an altitude of 50.4 miles. In 1991, his name was added to the Astronaut Memorial. X-152 crashed at Mud Lake, Nevada, and it was rebuilt after a landing accident on the 9th of November 1962, which damaged the craft and injured its pilot, John McKay. This aircraft was lengthened by 2.4 feet, had a pair of auxiliary fuel tanks attached beneath its fuselage and wings, and a complete heat-resistant ablative coating was added. The plane took flight for the first time on the 25th of June 1964. It reached its maximum speed of 4,520 miles per hour in October 1967, with pilot William Pete Knight of the United States Air Force in control. Thank you for watching, and if you have time, please subscribe to the channel.